New out-of-this-world discovery has some asking, what in the world is this? Take a look. NASA scientists say it's a comet. That's what they say. They've named it the 3-1 Atlas interstellar object, which was discovered last month.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
NASA's Perseverance rover might have just caught something mind-blowing above Mars. A faint streak of light slicing across the sky that could be the interstellar comet 3I Atlas speeding past the red planet. The photo was taken on October 4th, 2025, right when the comet's flyby was predicted to happen. NASA hasn't confirmed it yet, but the timing and geometry are almost too perfect to ignore. If verified, this would be the first time in history that an interstellar comet was photographed from the surface of another planet. In this video, we're diving into what Perseverance actually saw, how scientists are analyzing the evidence, and why this moment could flip planetary observation on its head. That night, Perseverance's navigation camera, the NavCam, recorded a thin, glowing streak cutting across the Martian darkness. At first, it looked like a meteor, which is extremely rare on Mars because of its thin atmosphere. But what made this shot stand out wasn't just the glow. It was when it happened. The streak was captured within hours of 3I Atlas, passing roughly 30 million kilometers from Mars, its closest known approach. Because the geometry matched every prediction, scientists immediately suspected a connection. However, NASA's public response was delayed because of the US government shutdown, leaving the global scientific community to analyze the mystery on their own. That's when astrophysicist Avi Loeb stepped in with a technical breakdown that's now gaining traction. Loeb explained that the streak wasn't the comet's actual body, but rather a motion blur caused by long exposure. Perseverance's NavCam takes multiple short exposures, just about 3 seconds each, and stacks them over several minutes to capture faint light. So, if something bright and fast crosses the sky, it'll appear as one long, glowing line. Loeb calculated that this particular streak represented about 10 minutes of movement, perfectly consistent with 3I Atlas flying by at roughly 67 kilometers per second. That speed fits both the physics and the timing, exactly what's visible in the composite. The streak's position also lines up with the comet's predicted path over Jezero crater. Still, scientists remain cautious. It could technically be a cosmic ray strike, a processing glitch, or even a small near-Mars asteroid, but the odds of that lining up with Atlas's flyby are ridiculously low. If confirmed, this would mark the first ever direct image of an interstellar object from another planet's surface, a monumental leap for robotic exploration. Even though faint, this single observation holds massive scientific value. Mars acts as a second observation point over 240 million kilometers away from Earth, giving astronomers a parallax baseline to refine Atlas's orbit and motion vector. When combined with telescope data from Earth, this helps map the comet's trajectory, spin, and tail behavior with crazy precision. Meanwhile, the European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter, TGO, were also tracking 3I Atlas from orbit. Their instruments were reading its reflected light and gas emissions, basically studying the glowing cloud of dust and vapor around its icy core. If Perseverance's photo overlaps with their observation window, it would be the perfect surface-level confirmation to pair with orbital spectroscopy. Together, these datasets could reveal not just where the comet was, but how its materials reacted to sunlight as it zipped by Mars. This kind of cross-planet teamwork is revolutionary. Rovers and orbiters, once meant only for local studies, are now turning into a solar system-wide surveillance network. By coordinating across planets, they're transforming the entire system into a connected web of observation. Perseverance's image, confirmed or not, shows that future in action. Of course, once the image hit the internet, speculation went wild. Some people looked at the stretched, cigar-shaped streak and jumped straight to alien theories, calling it an artificial object. But Loeb and NASA engineers quickly shut that down, explaining that the stretched look comes from image integration, not from shape. At that range, roughly 12,000 kilometers per pixel, Navcam couldn't possibly show any real detail anyway. Meanwhile, telescopes back home are still uncovering new surprises. Data from GUST, Hubble, and ESO's Very Large Telescope show that 3I Atlas's coma is packed with carbon dioxide, carbon monoxide, and trace metals. What's blowing scientists' minds is how its nickel-to-iron ratio swings wildly as it nears the sun, behavior never seen before in any known comet. Researchers think this might be caused by volatile organometallic compounds like nickel tetracarbonyl and iron pentacarbonyl, chemicals that evaporate at different temperatures. By comparing the orbiter's and telescope's readings with Perseverance's potential photo, scientists could finally link the comet's chemistry to its visible glow and tail activity, something never achieved with any interstellar visitor before. Now comes the verification phase. Teams are studying the Navcam's raw metadata, timestamps, pointing angles, and exposure sequences, and matching it against 3I Atlas's predicted movement. If everything aligns, direction, brightness, timing, that'll be the smoking gun scientists need to confirm it. ESA's orbiters are expected to release their October data soon. Mars Express and TGO both track the comet before, during, and after its closest pass. If their spectral readings show changes matching what Perseverance might have seen, then we'll have history in the making. A confirmed image of an interstellar traveler caught from the surface of another world. NASA's Mars Reconnaissance Orbiter, the legendary MRO, might also step into the spotlight. Its high-rise camera, though mainly built for detailed surface shots, can sometimes pick up bright flashes in the sky. If it happened to capture the same region as Perseverance, even the faintest glimpse could back up that mysterious Navcam streak. Meanwhile, observatories back on Earth haven't taken their eyes off 3I Atlas as it blazes toward the sun. Fresh data from Gemini South and the Very Large Telescope have dropped new clues about the comet's chemistry. Nickel compounds are vaporizing earlier than iron ones, which perfectly explains that wild nickel-to-iron ratio shift scientists have been scratching their heads over. This points to those metals existing as volatile, organometallic molecules, not trapped inside solid rock. And here's where it gets deep. These findings go far beyond one comet. They hint that interstellar objects might carry rich, complex chemistry shaped in alien star systems. That means every streak, every faint image, could be giving us a chemical snapshot of how matter evolves around other suns. Mind-blowing, right? If that streak truly turns out to be 3I Atlas, it'll make history, the first ever interstellar object photographed from another world. That single image would expand the very limits of what planetary exploration means, but even if it's not Atlas, the analysis still changes the game. It'll sharpen how we calibrate long exposure imaging on Mars, helping future missions separate true cosmic visitors from background noise or camera glitches. Here's the real takeaway. Robotic explorers like Perseverance aren't just digging in Martian dirt anymore. They're becoming eyes in a galactic network, a multi-world system watching space from different angles. This quiet transformation from local exploration to full-on interplanetary observation is reshaping how humanity studies the universe itself. Whether that streak was 3I Atlas or something else, one thing's for sure. Mars is now officially part of the search beyond our sun. Every new frame we capture pulls us closer to uncovering what's really out there. Don't forget to like, subscribe, and I'll see you on the next one. The universe has only just started talking.